Hello guys, my name is Desmond and I welcome you to my lesson for today. Ladies and gentlemen, are you able to see what I've got on my whiteboard? Is everything clear, guys?
Yes, sir.
Shreyas, are you also able to see? Was it you, Puti, who confirmed that everything is clear?
Yes, sir.
Okay, so ladies and gentlemen, for today's lesson, I've invited grade 10, 11, and 12 learners. So for everyone who's in grade 10, Shreyas, I know very well that you're in grade 10. So this lesson is going to expose you in terms of what to expect in grade 11 and grade 12. And again, you'll be able to notice the level of complexity when it comes to mathematics. So I'm glad with this kind of lessons, you'll be able to notice the direction that I'm taking you to on our private lessons. So Puti, just to remind me, in which grade are you? I see Lerato has joined. Lerato is in grade 11. Puti, I think you're in grade 12, if I'm not mistaken. Can you just confirm for me? Puti, remember to unmute your mic if you want to make a comment.
Yes, sir.
Which grade?
Ke nahana hore o na le bothata ba network ya kuku.
Okay, guys, so we are going to start with today's lesson. So I'm going to make it a special lesson in the sense that I want to spend much of my time showing you how I would solve this type of questions. When necessary, I'm going to consult you with you guys. So from time to time, I'm going to just check with each of you if we are still live and we're still on the same page. So ladies and gentlemen, there won't be much of me asking you questions in terms of how you'd approach this type of questions. I'm only going to be doing more in solving these questions, just so that you've got an idea of how to approach this type of questions. So obviously, we'll be doing mathematics paper 1, where you'll find most of these questions in your question 1, followed by normally it's sequence and series in question 2. But I would like, in preparation for final exams, remember guys, most of my lessons, I'm not really interested in preparing you for a class test, assignment, project, or whatever. The main aim is to prepare everyone for matric exams. I'm talking about final exams, ladies and gentlemen. So it's best in a sense that as you'll be learning throughout the year, you already know the direction in which you are heading. So it gives you an idea of what you should learn and emphasize the most during the year. So ladies and gentlemen, I'm going to take off this whiteboard and bring an empty one where I'm going to start with our very first question, which is allocated 2 marks. So we've got, I think it's 2x over there, which is 2x plus 1 close, that's equals to 0. And this question is allocated 2 marks. Ladies and gentlemen, very, very much important that at all times, you look at the given problem and ask yourself these questions. Is this an equation or an expression? Ladies and gentlemen, this is an equation. Why is it an equation? Because I can see an equal over there, an equal sign over there. So now, since this is an equation, what does it mean? It means I have to solve for the unknown. Ladies and gentlemen, what is the unknown? The unknown is represented by a letter, which could be any letter from A up to Z. In this case, they chose to use letter X, which means in the end, as part of my final answer, I could have one or two values of the unknown, which is X. So, Shreyas, it doesn't necessarily mean that at all times you'll be having one value of the unknown. In some cases, it might be two unknowns. It could also be three unknown. But in most cases, especially in grade 10, you will find that you need to find one unknown. In grade 11 and 12, in most cases, two unknowns. And still, even in grade 10, you're most likely to be asked to provide two values of unknown. Right. So now that I know my unknown is X, that means I need to solve. So, guys, what I can do in this case, obviously, for the fact that this is only allocated 2 marks, it's really not that much complicated. The common mistake that you would do with this type of problems, although it's a mistake, but it's not a deadly mistake. One would say, I'm going to multiply that by that, and again that by that. Let's do it and see what we get, ladies and gentlemen. So that means we're going to have 2x times x. It's obviously x squared. So x multiplied by 1, it's obviously x. Which sign, ladies and gentlemen? The sign that you got over there, which is a positive. And this is equated to 0. Can you see? So, ladies and gentlemen, it's more like now you've got that quadratic equation, which is in the standard form. Why? Because it's in that order of x squared, x. Your C value is 0. It's already equated to 0. Now that it's in the standard form, it means you need to factorize or find the factors. 3 years, it's very, very much important that you get, when you get to grade 11 and 12, you already know how to factorize. And you're very much confident in factorizing, which is what we'll be looking at next on our private lesson. So, ladies and gentlemen, when you get to this stage, you need to factorize. Obviously, the only possible way in which you can factorize is to take out x as common factor. So you've got x. Let me just quickly find a new marker, ladies and gentlemen. It seems like that one is a bit old. So you take out x as your common factor. Then you remain with what? Obviously, you remain with 2x plus 1. Remember, guys, you've got two terms, term 1, term 2. So there you've got 2, which is that 2, and you also have two values of x. So you just took out 1x. You did the same over there. Remember, you've got 1 over there, which is not necessary to write, which is that 1 over there. And this x, it's still represented by that same x. Obviously, anything else, you write it as it is. Ladies and gentlemen, can you see now? You are back to that original step. Very, very much important, ladies and gentlemen. So the reason why I said it's not a deadly mistake is because even if you did it this way, ladies and gentlemen, you will still go back to that original equation whereby you have now factorized. So now that you've factorized, it means you can say that value you equate it to 0, which is x, it's equals to 0. Then you equate the whole of this to 0. Then this is where you say, or 2x plus 1 it's equals to 0. Obviously, it means we are done with the first value of x. Now we need to solve for the second value of x. Shreyas, this is where I'm now teaching you. Obviously, we've been doing more of this type of equations, which is grade 10 stuff. But can you see, when you get to grade 11, they give you something similar to that. When you get to grade 12, they give you something similar to that, which means when you get to grade 11, I'm now going to be teaching you how to approach this type of equations. When you become good in solving problems, especially that you're in grade 10, that means when you get to grade 11 and 12, you won't struggle with performing mathematical calculations. All that you need to do is just to be able to know the approach of each and every question. Mr. Tele, if you're also on the line, the same explanation goes to you. So now we are at that stage where you need to solve for x, which means you firstly transpose. Obviously, this is more like an equation where you still need to solve for the value of x. So you transpose. When you transpose, you change the sign of the original term. So anything else remains as it is. You transpose. That means obviously you've got 0. No need to write 0. Then you change the sign of that term. So it was positive 1, it's now negative 1. Therefore, you need to remove that 2. How do you remove that 2? You just divide by 2. What you did on the left, you do on the right, which means your x value is equals to negative 1 over 2, which is negative half. Very, very much important, ladies and gentlemen, massively important. Something that I've learned when I was in grade 10, of which I'm very much glad that I learned. Guys, for me, when I was in grade 10, 11, and 12, when it comes to question 1, I had to take all the marks. I had to be sure that all the marks are in the back because I was able to prove if my final answers were wrong or correct. So, ladies and gentlemen, how do you mark for yourself? So, obviously, since you said x value is equals to 0 or x value is equals to negative 1, it means wherever you see x on that equation and substitute whatever calculated x value, when you punch its equals to on your calculator, you have to get 0. If you do not get 0, then it means your final x value is wrong. So, ladies and gentlemen, what I'm saying is that obviously this is that place of x into 2 into x plus 1. Ladies and gentlemen, when you substitute the first x value there and there and punch all of this on a calculator, you must get 0. Why 0? Because on the given original equation, ladies and gentlemen, the whole of this is already equated to 0. So now let's start with our first x value. So that means when you substitute 0 there, and punch all of this on a calculator, you must get 0. So guys, if you're still with me, you can take out your calculator and say open bracket 0 close open 2 into 0 close plus 1 close, it's equals to, ladies and gentlemen, I'm getting 0, which means the first x value is correct. Ladies and gentlemen, let's now prove the second x value. So I'm just going to go back to my original equation over there and punch negative 1 over 2. Remember to change it in 2 position. So negative 1 over 2. Punch it equals 2. I'm getting 0. So guys, this is an indication that already I've secured 2 marks out of 150 marks. the first x value is correct. The second x value is correct. To all grade 11s and grade 12s. Guys, are we all on the same page before I move to the next question? Guys, are we all on the same page before I move to the next question?
Yes, sir.
So, ladies and
Yes,
gentlemen,
sir.
out of 150, I've already secured 2 marks. So, guys, let's now move to the next question. So, there's something very much interesting about question number 2. Ladies and gentlemen, you're given a hint, correct to 2 decimal places. To me, ladies and gentlemen, that sentence alone, it simply says, don't stress that much about trying to use your head to factorize that. Just straight away use the formula. Very, very much important, ladies and gentlemen. So I'm going to write down all of that given problem. So we've got 5x squared plus 2x minus 6. This is equated to 0. This equation is allocated 2 marks, and they say correct to 2 decimal places. Ladies and gentlemen, it's very, very much important that you know the quadratic formula by heart, because at all times you'll be using that formula. Guys, it's in your best interest to never forget this formula, because whether you're in grade 11, 12, even at tertiary level, you'll still be using this formula. X is equals to negative b plus or minus square root of b squared minus 4ac all over 2a. Someone remember to mute your mic. So, ladies and gentlemen, Trias, this is a formula that is given on the formula sheet, especially when you're in matric, they give you these formulas. But when you're in grade 10 and 11, I don't think in your exams they give you the formulas. Especially, who is it? Lebohang, can you try mute your mic? Remember, guys, if you forget to mute your mic, I'm able to mute your mic, but then I might forget to unmute in case if you want to ask a question. So at all times, remember to check if your mic is muted. So, ladies and gentlemen, this formula, I'm 100% sure it's given when you're in matric. I'm just not sure if in grade 11 on your final exams they give you these formulas. But this one, please do make sure that you know it by heart. Ladies and gentlemen, I'm given that equation. I'm going to ask myself a few questions. Is this an equation or an expression? Ladies and gentlemen, this is an equation. If it's an equation, what does it mean? It means we must solve for the unknown. What is the unknown? The unknown is a letter which is represented by letter A or any letter up to Z. But in this case, because I know in mathematics, they love using or representing the unknown by letter X. So that means in this case, I must solve for the value of X. What does it mean when I'm solving for X? It means in the end, ladies and gentlemen, I must say X is equals to whatever, because this is a quadratic equation because of that X squared. It means I'm going to have 2 values of X. Massively important, ladies and gentlemen, that you are aware of this information where you need to learn how to interpret the given problems. In that way, you know exactly how your final answer should look like. So, ladies and gentlemen, obviously you need to ask yourself if that equation is in the standard form. What makes it to be in the standard form? That's if you've got obviously the A, B, and C value, and when the whole of this is equated to 0, you know it's in the standard form. And ladies and gentlemen, most importantly, if your A value is positive, then you are 100% sure that you can apply that formula. Guys, what is the value of A? It's positive 5. What is the value of B? It's positive 2. What is the value of C? It's negative 3. Ladies and gentlemen, in mathematics, it's very, very much important that at all times, when you mention the number, you firstly mention the sign. Obviously, we know this is 2, we know this is 5, and we call this negative 6. So, ladies and gentlemen, if this is negative 6, then this is positive 2. This is positive 5. Ladies and gentlemen, just get used to start mentioning, firstly mentioning the sign of a number. Very, very much important, ladies and gentlemen. So guys, it's just a matter of substituting on the formula. And most importantly, be careful, ladies and gentlemen. In most cases, they like giving a negative B value so that it confuses you on that first part. But otherwise, with you attending this type of lessons, ladies and gentlemen, you know very well that at all times, when you substitute in brackets. Okay, even if it's a positive value. So that means our B value is 2. So on that formula, wherever you see A, you substitute with 5. Most importantly, in brackets. Where we see B, we substitute positive 4. Positive 2. Most importantly, in brackets. Where we see C, ladies and gentlemen, most importantly, we substitute in brackets. At this stage, when you substitute, write positive or a negative over there. What is our B is 2. Ladies and gentlemen, most of the time, you forget to square that B. Okay, do not just say a 2, but most importantly, square. Minus 4. What is our A value? It's positive 5. What is our C value? Is negative 6. Ladies and gentlemen, the whole of this is divided by 2 into our A value, which is 5. Guys, very, very much important. Do not, when you write that over, don't just write a line, ladies and gentlemen, which starts somewhere there as if you are not sure if that over is for the whole of this. So otherwise, it's more like you're saying negative 2, in between you've got plus or minus, then the whole of that. Ladies and gentlemen, that over started from there all the way up to the end, which is an indication that the whole of that is divided by 2a. Okay, massively important. So ladies and gentlemen, at this stage, this is where you know you're going to separate, because you're going to punch the whole of this by firstly starting with a positive sign, and secondly starting using a negative sign. So this is where you can confidently say x is equals to that, or x is equals to whatever that you get when you punch on a calculator. Ladies and gentlemen, this is that time where you say over negative into 2 close. Obviously, we start with that sign of a plus square root into 2 close squared. Very, very much important, ladies and gentlemen. Minus 4 into our A is 5, negative 6. At the bottom, we've got 2 into our A value, which is 5. This is equals to, I'm getting negative 1 plus square root of, what is it, as 31. The whole of this divided by 5. Okay, so ladies and gentlemen, I'm just going to go back to that calculation and edit that positive and replace it with a minus. It's equals to, this is what I'm getting, ladies and gentlemen. Very, very much important. I'm getting negative, then I've got that line of over, then I've got this is 1, ladies and gentlemen. So let me just write it correctly over there to say this is 1 plus square root of 31. The whole of that is divided by 5. Okay, so most importantly, guys, they said to you correct to 2 decimal places, which means they want your final answer in a form of a decimal, which is rounded off to 2 decimal places. Okay, so guys, there's this sign at the top of delete, which is SD. We use that sign to convert from a fraction to a decimal. So I'm getting negative 1,3 1355 blah blah. Obviously, you know, when you round off to 2 decimal places, you check for that third number. If it's from 4 downwards, you don't round off. If it's from 5 up to 9, you can add to that second number, which means in this case I've got that, ladies and gentlemen. So now I can go back to that calculation, ladies and gentlemen, and change or convert it to a decimal. I'm getting 0,91355 blah blah blah. Correct to 2 decimal places, it's 0,91, ladies and gentlemen. Therefore, it ends there. It seems like a very lengthy calculation, but trust me, ladies and gentlemen, if I had to do this without speaking and everything, guys, I could have got to that answer without even having to write all of this. So I just know how my final answers look like, and it's just a matter of writing. Ladies and gentlemen, you might score a mark for correct substitution. Remember, in mathematics, they don't give you a mark for the correct formula. Okay, so you might score a mark for correct substitution, and again for both of those simplified. What is it, ladies and gentlemen? Someone is laughing, and they're distracting me. But anyway, it's fine. It's something which is funny, and I want to laugh, but I'm unable to laugh. So my math teacher used to say, when there's something funny in a math class, you just say ha, or you say ahi, then you'll finish with the laughter at the end of the lesson. So ladies and gentlemen, I'll just apply that to say ha, then it's done. So guys, obviously, you might also score a mark for that part of a simplification. So, Shreyas, can you see how important it is that when you are in grade 10, you learn how to simplify? So it's 2 things that you need to learn. In most cases, you are given an equation, especially when you're in grade 11 and 12. They know within that equation, there is a bit of simplification that needs to be done. So this is where you simplify all of that. And this is the simplified form of that lengthy or long problem. So you simplify it further by writing it in a form of a decimal. So ladies and gentlemen, this is how you score your 3 marks. Guys, before I move to the next question, is there someone who's got a question?
Yes, sir.
What's the question?
Please re-explain after substituting.
You need explanation after substituting.
Yes, how did you get? It was negative then 2 in bracket So how do you get -1?
Okay, so let me explain. Firstly, you need to be having this type of a calculator which has got that fraction button. So I'm going to punch all of this on my calculator. So fraction button, negative into 2. I start with a positive sign, square root of into 2, close squared, minus 4 into my A value is 5, C value is -6, 2, my A value is 5. It's equals to, I'm getting -1 plus square root of 31 all over 5, which is that one. Remember, I've started with a positive sign over there. And according to this formula, you start with a positive, then after you use a negative sign. So I've used a positive sign, and this is what I got. Now I need to go back to that same calculation to change that positive sign and replace it or use negative sign. So I'm deleting that sign and I'm punching a negative sign. Then I say it's equals to. Then this is the second value that I'm getting, which is -1 plus square root of over that. A promise, does it make sense now?
Yes, sir, it does.
So does it mean you will then be able to do all of this?
Yes.
Ladies and gentlemen, anyone who's got a question before we move to the next question? Guys, I'll just make an assumption that we are all on the same page. Remember, guys, this lesson is being recorded, so just in case if in future you need to refer to something, you can just request for a link. Then I'll send you a link where you can just catch up. Ladies and gentlemen, this is question number 3. So I'm just going to quickly write it down and try to do a bit of interpretation and solve the problem. Is greater than 3x, and this question is allocated 4 marks. Shreyas, this is another type of a problem where it's not an expression, and again it's not an equation. What makes it not to be an equation? It's because of that sign. What is the name of that sign? We call it inequality. Inequality sign. So Shreyas, this is the only part that is left for you to learn. We've done expression and equations. Before the end of the year, you should learn also about inequalities. Then you'll be ready to solve any type of a problem. So remember, those signs, it can only be greater than or it's equals to, less than or it's equals to, or just greater than or just less than. So there's a special way in which we solve inequalities, ladies and gentlemen. But generally, the procedure it's almost the same as if you are solving an equation. So, ladies and gentlemen, because of that x squared, we call this type of problems quadratic inequalities. So, what makes an equation to be a quadratic is because of that letter squared, not just x squared, but letter squared. Remember, it could have been A, B, C, D, E, F, G, all the way up to Z. And also there, it could have been any letter. But we know in mathematics, they like using letter X. So ladies and gentlemen, the first step that you need to do is to write the whole of that in the standard form. So it's going to be 2x squared. So you transpose. Why do you have to transpose? Why do you have to write it in the standard form? It's because you can only factorize once it's in the standard form, ladies and gentlemen. So when you are given a quadratic equation, a quadratic inequality, at all times, you want to write it in the standard form where you want to have a positive A value, have the value of A, B, and C, and again equate it to 0 if it's an equation, or otherwise, if it's that inequality, you just want to have 0 on the right side of that inequality sign. When we transpose, we want to have it in this manner of ax squared plus bx plus c. It's either less than or greater than whatever it's equals to. You just want to have 0 on the right side of the that sign. So obviously you're going to start with that which has a number x squared, which is that one, followed by one with a number and a letter of which is that one. So already we are writing them in the standard form. Remember, when you transpose Shriyas, you change the sign of the original term to its opposite sign. So obviously, the opposite sign of positive is minus. The opposite sign of minus is positive. Ladies and gentlemen, the opposite sign of multiplication is division. The opposite sign of division, it's multiplication. Very, very much important, ladies and gentlemen, that you are aware of this type of information. It only makes sense when you are able to apply it. So obviously, you write whatever that you had as it is, and the whole of that is greater than 0. Ladies and gentlemen, most importantly, that inequality sign only changes when you've got negative a, because obviously you will need to divide each term by negative sign, which means each and every term changes the sign. Guys, now it seems to be in the standard form. If it's in the standard form, let's now, ladies and gentlemen, factorize. So this is the part where you factorize. Shriyas, at all times, it seems like when you've got a quadratic equation, which means you've got ax squared, bx squared, cb, a, b, c, d, e, f, g, all the way up to z squared. You need to get to a point where you write that problem in the standard form, and then from there you factorize, which means it's very, very much important that you and I do those factorizations on our sessions. So, ladies and gentlemen, let's try to factorize this thing. Let me see. Obviously, I've got 2x there, I've got x over there. What else? Obviously, 2 times 1 is equals to 2. What if I've got 1 over there? Remember, guys, if this seems to be complicated for you to factorize, you can use that formula, which is only being used in grade 11 and 12. It's unfortunate in grade 10 areas that formula is not there, but I'm going to teach you that formula because also in my case, I learned that formula myself when I was in grade 10. And from there, I never got factors wrong. So, ladies and gentlemen, we've got 2x, we've got 1x, 2 over there in terms of the signs. Let's see, I remember saying the bigger number between these two takes the sign of the middle term, which means it's going to be negative because the middle term is negative over there, which means this is going to be a positive. So remember, guys, factorization is one of the most important part where you need to be sure, because if you get it wrong, going down everything is wrong. So let's test it. That times that, it's equals to 2 x squared. That times that, let's see, we're getting a negative, it's going to be negative 4x. Then this times that, it's going to be positive x. This times that, it's going to be negative 2. So that doesn't really matter that much. So do I have the like terms? I've got those which are like terms. So this, I just write it as it is. Negative 4 plus 1 is equals to negative 3x. That obviously is minus 2. So this is the same as that, which means the factorization is correct, which means the factors are correct. So in this case, ladies and gentlemen, I had to use my head, but otherwise I did not have to stress myself this much, because I could have used that formula. So ladies and gentlemen, remember, we're dealing with inequalities, which means when you get to this stage, you need to get what we call critical values, ladies and gentlemen. Critical values, it's more like you solve for x in a nutshell, ladies and gentlemen, which means you've got 2x plus 1, you can equate it to 0, or x minus 2, you can equate it to 0. Lerato, this is where you are allowed to use an equal sign when you're dealing with inequalities. Remember, throughout the calculations, we've been using that inequality sign. Only when you find the critical values, you can use an equal sign, because the main aim is not really to get those equations over there. It's mainly to get the values, which are called the critical values. What are the critical values? Obviously, now that you have equated that to 0, 3 years, this is where you are. You solve for the unknown, which is x. So that means you transpose that. Remember, it changes a sign. You do the same there. You transpose. You've got a positive 2, which means the first critical x value is 2. The second critical value, obviously, it's negative 1 over 2. Remember, you divide it by 2. What you do on the left, you do on the right. Why did you have to divide by 2? It's because you wanted that to cancel so that you remain with x, which is equals to negative half. So, ladies and gentlemen, why did you have to find the critical values? It's because you have to represent them on a number line. Ladies and gentlemen, remember, this is that x-axis. So obviously, you start with your negative value followed by the positive value. Or otherwise, if you had negative 2 over there, you were going to start with negative 2, then followed by half. So in a nutshell, it means you start with a smaller number followed by a bigger number. Guys, remember, when it comes to inequalities, when you're dealing with greater than it's equals to, you've got that circle which is shaded. When you're dealing with less than or is equals to, you've got that circle which is shaded. When you've got a greater than, it's just a circle. When you've got a less than, it's just a circle. So that means greater than or is equals to it, what makes it to be shaded? Less than or it's equals to it, what makes it to be shaded? If it's just that, you don't shade. Guys, where do you represent those on this number line? Remember, ladies and gentlemen, at the top of your critical values, that's where you're going to have that circle, which is an empty circle or a shaded circle. Is it a shaded or an empty circle? Ladies and gentlemen, you've got greater or it's equals to, you've got greater or it's equals to, which means it's a shaded circle. So I'm going to shade it, ladies and gentlemen. So guys, next step is for you to know, where are you having positive values, where are you having negative values, where are you having negative or positive values. So ladies and gentlemen, you are going to use any number in that direction, any number in between these two critical values, any number from there in that direction. So I normally use a number which is bigger on both of these numbers. So for example, let's use 10, ladies and gentlemen. Remember, you can use 10, 1,000, a million, as long as it's a number which is greater than 2. If you use numbers in between, we know in between we've got what is it? We've got 0, we've got 1, we still have 1, 1.5, which is 1.5 before we get to 2. So, okay, let's start from this side going in that direction. So I can use -10. I can use 10 on that other side. I can use, let's say, 0. The main aim is to find if I punch numbers on this side, I'm getting a positive or a negative value. The main aim is to check if I punch any number in between, I get positive or a negative value. The main aim is to check if I punch, I'm getting a positive or a negative value. Ladies and gentlemen, where do you punch all of that information? You punch it on that original, on that, I can't say equation because this is not an equation. Let's say on that problem which is in the standard form. So I'm going to have 2 into remember I said I'm going to start with -10 close squared minus 3 into -10 minus 2. Then I'm getting positive 228. But remember, I'm only interested in knowing if I'm getting a positive or a negative value. So I'm just going to edit that -10 and make it positive 10. So I'm getting a positive value, which means, remember, that 10 is on this side. So I'm getting a positive value. So now I'm going to use 0 because I need to know in between, am I getting positive or negative value? So I'm just going to delete that one over there, delete that one. So I'm getting -2, which means in between I'm getting negative values. Ladies and gentlemen, according to that, remember, from time to time we refer to that equation which is in the standard form and not the original equation, unless if the original problem or quadratic inequality is already in the standard form. So because in this case it's not in the standard form, I had to rewrite it in the standard form. That means everything going down, if I need to work out something, I need to refer to that equation which is in the standard form. So ladies and gentlemen, according to this, Shreyas, we are simply being asked for which values of x, when substituted there, you get a number which is greater or equals to 0. Okay, obviously we know when we substitute these critical values, we get 0. But from there, is it in that direction or in that direction where you get values which are greater than 0? What are values which are greater than 0, ladies and gentlemen? So that means positive values are greater than 0. Ladies and gentlemen, negative values are less than 0. Okay, but in this case, we are only interested in values which are greater than 0. Don't worry that much about that greater than or equal sign over there. So Shreyas, this thing is greater or equals to. This thing is less than or equals to. This is just greater than. This is just less than. In this case, we are dealing with greater than or equals to. Guys, we have just noticed that when we substitute values in that direction, we are getting positive values which are greater than 0. Ladies and gentlemen, we've noticed when we substitute on that equation which is in the standard form, when we substitute with values in that direction, we get values which are positive, of which it means they are greater than 0. Okay, so that means your final answers, you say X. I normally just use that arrow there. You say less than or it's equals to 0. Then you say, oh, wait, guys, it's not equals to 0, but you use the critical values, negative 1/2. So I used that sign because it's for that critical value. That's why I had to write the critical value there. So now let's get to that sign and its critical value. So you're going to say X. You use that sign is greater than, but remember in this case it's greater than or is equals to. Then you say greater than or is equals to. The critical value is 2. Ladies and gentlemen, this type of equations require a lot of practice, but you understand better when you are able to solve, because you only worry about trying to represent those final values. And I came to a realization thanks to Dimpo. I'm not sure if she's on the line. Innocentia, okay, she's there on the line. She was able to make me aware that when you've got greater than or equals to 0, your answers are always separate. But when you have less than or maybe less than it's equals to, that's when you've got a combined answer. You know those type of an answer which is like this, where you've got a value there and a value there. So you normally have this type of an answer if you've got less than, or if you've got less than or is equals to on the original equation, or otherwise on your standard equation. Because remember, you can be given an equation similar to that one or a quadratic inequality similar to that one, whereby in the end, because of a negative a value, you might end up having to change that. So that is the reason why I'm saying at all times, be obsessed about getting your quadratic equation or inequality in the standard form. In that way, you are able to tell if your final answer is going to be a separated answer. When I say a separated, I mean where you've got that or that. And if you've got a less than on your a problem or inequality, on your quadratic inequality, which is in the standard form, if you've got a less than, you're going to have that single representation of an answer. Ladies and gentlemen, you are most likely to find a mark for writing it in the standard form. I'm not sure about the factors, otherwise you might score some marks there and again get an answer for that representation on the number line, and again get your final answer for your x values. Ladies and gentlemen, anyone who has got a question before we move to the next question? Guys, does it mean you understood that explanation?
Yes, sir, we understand.
I'm very, very much happy, ladies and gentlemen, that you all understood all of that, because I thought you were going to be confused. But because, Shreyas, this is not our first lesson where we solve this type of a problem. So there are some learners who usually or on a regular basis attend my lessons, so they fully understand my interpretation, of which I've noticed, Shreyas, that you also understand my teaching style. So, ladies and gentlemen, let's now move to question number 4, which is simultaneous equation. Ladies and gentlemen, why is it being called simultaneous equation? It's because this is where you need to solve two unknowns simultaneously, or otherwise where you need to solve them at the same time. Ladies and gentlemen, this question is allocated 6 marks. So I'm just going to quickly write down that equation. So you've got y plus x, it's equals to 2. Then I'll take this as equation number 1. Equation number 2, I've got x squared plus 3xy plus 8. This is equals to, I think it's 8. Then let's say this is equation number 2. Ladies and gentlemen, let's just quickly check if I've copied it correctly. I've got y plus x equals to 2, x squared plus 3, xy plus 8, that's equals to 0. And the whole of that, okay, so this is what we call a simultaneous equation. Shreyas, I want you to notice something. Although this problem might be allocated 6 marks, it's more like within this 6 marks, you've got 3 plus 3. What is 3 plus 3? You've got 3 marks worth of calculation. Simultaneously, you need to also score 3 marks, 3 marks worth of calculation. So in short, it's more like you perform 2 calculations in one problem. So it's not really that much complicated. I'm going to also guide you in terms of how you approach this type of problems. Ladies and gentlemen, at all times, ladies and gentlemen, when you're given a simultaneous equation, ask yourself this question. Between equation 1 and equation 2, which one is less complicated and which one is more complicated? In most cases, equation 2 is more complicated than equation 1. So obviously, when I say which one is more or which one is less complicated, I'm simply saying between these 2 equations, which one can you simply use to make the unknown the subject of the formula? Can you see? Trying to make the subject of the formula x or y the subject of the formula out of this equation, it's a little bit, not really a little bit, it's too much of stress, ladies and gentlemen. But you can easily make either x or y the subject of the formula on equation number 1. So that is the first thing or the first process that you need to go through. The second process, you need to decide between y and x. Which one can you make the subject of the formula? So you are still guided by your equation number 2. It's very, very much risky to make x the subject of the formula. Why? Because you are going to substitute too many times. You're going to substitute it there. You are still going to substitute it there. So it's not a good idea, ladies and gentlemen, to make x the subject of the formula. Therefore, it's best to make y the subject of the formula because you are only going to substitute it once, which is less of work, ladies and gentlemen. So guys, this is how I approach this type of problems. So now that I've noticed that it's best to make y the subject of the formulas, 3 years, to make y the subject of the formula, you simply want to remain with y on the left side of the equal sign, and you move everything to the right side. This is equals to, obviously, on the right side, 2 was always there. So start writing 2 because it has always been there. Then you can now write a visitor. Our visitor in this case is x. Because he's a visitor, change their sign. Okay, change their sign. Ladies and gentlemen, this reminds us that this is a visitor. So originally they had a positive sign. So this is what you call equation number 3. Okay. So when we proceed, we can now substitute this into that. So that was the main aim for us to derive equation number 3. Ladies and gentlemen, it seems like I'm running out of a battery. I'll need a power bank. So I'll just have to quickly make sure that I get um, that power bank so that I do not run out of battery in this interesting lesson, ladies and gentlemen. So let me just do that and make sure that the power is on. Ladies and gentlemen, let's now continue. So guys, where were we? I was saying the main aim of you making equation number 3 is for you to be able to substitute that equation number 3 into equation number 2. Okay, so now let's substitute. 3 years. That is why at your early grades, I'm teaching you how to substitute in brackets. It's massively important that at all times you substitute in brackets. So wherever you see y trias, wherever you see y in that equation, we substitute all of that. Okay, so we've got 3x into 2 minus x. Anything else remains as it is. So, trias, as you can see, we've got an equation. So, in lower grades, they don't give you that type of a problem. They just give you this and say solve. So when you get to grade 11, they give you this type of equations. The difference is the level of complexity. When you get to grade 12, it gets even more complicated, but the approach is the same. And if you are confident in solving for the unknown, you will never struggle. Even when you get to tertiary level, it doesn't get any complicated than it is when in grade, it is in grade 12. So, ladies and gentlemen, let's now solve for the unknown quickly. Obviously, this remains the same. We want to sort out that part of the brackets. Remember from BODMAS. So we firstly need to dissolve the brackets. Obviously, that by that, that by that. So that means we've got 6x squared. That by that, it's minus 3x squared plus 8, it's equals to 0. Do we have like terms trias? It seems like we do. That term and that term, we've got x squared over there. So it seems like it's 1x squared minus 3x squared, and you get negative 2x squared. Did I make a mistake somewhere?
Yes,
It seems
sir.
like I did. It seems like I did. That one over there, isn't it? Ladies and gentlemen, thanks very much for noticing that mistake. So I'm going to quickly correct that mistake over there. So guys, I'm pretty much sure that some of you suspected that it could have been a mistake. So ladies and gentlemen, please do make sure that you make a comment if you notice I'm making a mistake, or otherwise if I'm doing something that you do not understand. Please make sure to just ask if it's either yourself or myself that I'm making a mistake. So, ladies and gentlemen, I'm going to tell you a very quick story. I'm very much glad that I made that mistake, which is something that I teach a lot in most of my lessons. Ladies and gentlemen, you become wiser when you make more mistakes. So, the the most important thing that I did when I was in high school, it was to make more mistakes than everyone else in my class. Why did I have to make those mistakes? It's because when you make as many mistakes as possible, even when you have to teach someone, you already know the types of mistakes associated with those particular problems that you'll be doing. I can tell you, ladies and gentlemen, you won't repeat those mistakes in exams. Once you make a mistake, you are able to quickly recover and say, no, it seems like I've done a mistake, but let me just quickly try to retrace and check where I made a mistake. So if I continued with that mistake and notice I made a mistake, I already know where to start checking for that mistake. Ladies and gentlemen, obviously, because you know how BODMAS works, you are firstly going to check there because you know this is where you substituted, and on your next step, you need to sort out your brackets. So, guys, at all times when you're practicing, and also when I'm doing this type of lessons, for every mistake made, make note of that mistake because there is a value in every mistake. When you practice, when you write your tests, your classworks, your assignments, your projects, and also the homeworks that I'm giving you guys, do not copy, do not be obsessed with getting the correct answers. Make those mistakes because you're going to help me to notice those mistakes and make my lessons even better and make those mistakes as well so that you are able to learn from those mistakes. It's very painful to make a mistake in an exam and not know where that mistake could be. So, ladies and gentlemen, let's now proceed. I hope you find that information valuable. So obviously we've got that and that which gives us that. So we've got negative 6 over there, positive 6 over there. So it just remains as positive 6 plus 8. This is equals to 0. Guys, it seems like we've got common factor of 2 in each and every term. So let's divide by negative 2, negative 2, negative 2. Shreyas, why do we divide by negative 2? It's because this is a quadratic equation and we need to get it in the standard form. So when you get it in the standard form, you need to have a positive a value. That's why we need to get rid of that negative value. So if we did not have a common factor of 2, let's say there we had 1, that means we were not going to divide each term by 2, but instead we were going to divide by negative 1 just so that we remove that negative. But because 2 is divisible in each term, then we just divide by negative 2. Remember, what you do on the left, you also do on the right. So that cancels, which means it remains with x squared, and then that is obviously negative, what is it? It's 3x. That obviously is negative 4. It's equals to 0 divided by negative number. It's equals to 0. So now this is where you can factorize because it's now in the standard form. So easily, this one is easy. You can just say xx. If you don't have a number there, you can just say xx. Then here, you know, 1 times 4 can give you 4. And 2 of these values can give you 3. In terms of the signs, the bigger number between these two takes the sign of a middle term. What is the sign of a middle term? is negative. What is the bigger number? It's 4. Therefore, that 4 takes negative sign because C value is negative value. Then we are supposed to have a positive sign over there. If it was a positive value, then we're going to have negative factors. That means our x value, obviously the whole of this is equated to 0. You transpose, you get negative 1 as our first x value. Then you say, oh, obviously you know the whole of this is equated to 0. You transpose, then x is equals to 4. So, Shreyas, can you see, when you get to grade 11, grade 12, you no longer need to do those unnecessary calculations. Already you know this is equated to 0. You just transpose right away because that step in between is not allocated mark. It's not allocated a mark in grade 11 and 12 because they assume you have scored marks in grade 10 to bring you in grade 11. So now that we have got the x values, remember we are solving simultaneously. So that means we also need to get the y values. So this is where you substitute into your equation number 3. You say y is equals to, remember, this is how your equation number 3 looks like. You're going to firstly substitute with the first x value. You say 2 into negative 1. You punch all of this. This is positive plus that. Then you get 3. Then you say, or you say y is equals to 2 minus 3. Remember, you are using equation 3 to calculate the corresponding y values. So if we made y the subject of the formula, that means you're going to have y is equals to that, y is equals to that. Then you still go back to equation number 3 to calculate the x value or the corresponding x value. So now you substitute. The other x value, it's 4. Obviously 2 minus 4, it's negative that. So that means where the x value is negative 1, the corresponding y value is 3. Where the x value is 4, the corresponding y value is negative 2. Ladies and gentlemen, this is how you get your solutions to this problem. You are most likely to get a mark for deriving equation number 3. All of these not allocated marks until you get to that standard form. And they can just give you some marks for the factors, ladies and gentlemen. And again, where else can you score some marks? They can just give you marks, ladies and gentlemen, for getting the x values. And again, they can also give you a mark for final y values. So we've got 2, 4, 5. So somewhere, ladies and gentlemen, they will give you a mark. Somewhere they will give you a mark. But this is usually not allocated some marks. This is just for you to represent, to say, this is the x value, this is the corresponding y values. So I'm not really sure in terms of exactly where they give you these marks, but otherwise you might find that maybe they give you a mark there, and again they give you a marks for the x values. So maybe they don't give you a mark for those factors. Ladies and gentlemen, before I move to the next question, is there someone who's got a question? Ladies and gentlemen, are we all on the same page? Did you all understand that calculation?
Yes, sir.
Guys, are you sure you are not scared to say you don't understand?
We understand, sir.
Okay, 100%. So now I'm just going to remove all of that. Shreyas, are you still on the line?
Yes, sir, I'm here.
100%. So guys, let's now move to question number 5. Remember, ladies and gentlemen, the main aim is for me to answer all of these questions. From there, I might be completely out of question 1 for general lessons, which means I might be doing a private lesson where I'm dealing with question 1, of which you might still be able to join but not be able to engage. So, guys, it becomes more interesting when we are doing these lessons where everyone is able to participate, because with you asking a question, it helps us to expand our explanation, and again you are able to learn from each other. So ladies and gentlemen, now we can move to that question which is allocated 3 marks. This is question number 5, which is 2 minus 16x to the power negative 3 over 2, and the whole of this is equated to 0, and this is allocated 3 marks. Ladies and gentlemen, this is an interesting question, which is a solve for x type of a problem. Ladies and gentlemen, is this an expression or an equation? Shreyas, are you confident enough to explain to us if this is an expression or an equation? And just keep on with that explanation until you get to that stage where you can say, now I can solve. Are you confident enough to tell everyone what type of a problem is this?
Yes, sir.
Go for it.
So this is an equation because of the equal sign, and we have to solve for the unknown, which is represented as x.
So, can I take it from here?
Yes, sir.
100%. So, ladies and gentlemen, this is an equation because of that equal sign, which means we have to solve for the unknown, of which in this case, the unknown is represented by letter x. What does it mean? It means in the end, we have to say x is equals to whatever that we calculated. Okay, do not give anything other than a x, which is equals to a certain number. So guys, in this case, remember guys, you just want to have one term on one side being just that term as a positive number. Ladies and gentlemen, I'm going to move that 2 to the other side, and obviously it changes a sign. So what remains on this side, I just write it as it is. So I'm going to remain with negative x, 16x to the exponent negative x over 2. This is equals to negative 2. Remember that 2 changes a sign. So I need to remove that negative over there. I need to remove that negative over there. So you remove that, ladies and gentlemen, by dividing by negative 1. So that means you are remaining with you're remaining with positive x to the exponent 3 over 2, and this is equals to positive 2. Very, very much important, ladies and gentlemen, massively important. So remember, it doesn't necessarily mean that at all times you can only transpose a number. You can still transpose the whole of that term. What do I mean by that? You can still have 2, or maybe let me just remove all of that so that you you see another way in which you can do this without doing a lengthy calculation. So I can just transpose that term. So I'm going to remain with 2, then it changes the sign, it becomes positive 16x to the exponent negative 3 over 2. Can you see? So because this x is on the right side, I can still just swap. It's still the same thing, ladies and gentlemen. I can still say 16x squared, 16x to the power 3 over 2, it's equals to 2. It's the same thing. It's more like you are saying 2, it's equals to y. This is still the same as y, it's equals to 2. Can you see? So do not think you can only transpose a number. You can still transpose a term which has got the unknown or a letter. So ladies and gentlemen, now that I've got this, what is my next step? Remember, the main aim is to remove everything which is attached to the unknown. So this is what we've got. We've got that which is normally known as the coefficient, then you've got the unknown, then you've got the exponent. Okay, so normally with this type of problems, when you remove everything associated with the x value or the unknown, you firstly remove the coefficient. After you have removed the coefficient, it means you're going to remain with x to the power. Now that you are remaining with the power, the next thing that you need to remove is the power. After you removed the power, you remain with x, which is equated to your final answer. Ladies and gentlemen, you need to be aware of this type of information so that you've got a direction. So now, let's remove the coefficient. What is our coefficient in this case? 16. How do we remove that coefficient? You divide by 16. Whatever you do on the left, you do on the right. Why did you have to specifically divide by 16? It's because your coefficient at 16 and you want to remove that 16. What are you remaining with? Remain with x to the exponent negative 3 over 2. What are you remaining with on this side? You can just punch this on a calculator and see if it has its simplified form. So 2 over 16, it's 1 over 8. It's 1 over 8. Okay, so ladies and gentlemen, what we need to do now is to remove that exponent or that power. Okay, so this is the power that we've got. So for us to remove that power, we are going to multiply by the reciprocal of that power. So if you had x to the power 2, you were going to multiply that exponent by 1 over 2. Why 1 over 2? Is because you know 2 is the same as 2 over 1. So you just swap or do the upside down, or I think the best way to use is swap. So if it's positive 2, you multiply by positive value, but you swap. In short, if you had y to the exponent negative 3, you know there's over 1 which is not necessary to write. So that's why you multiply by the same sign, which is negative. You swap the 3 and the y. In this way, that cancels, that cancels, that cancels. You remain with y, which is equals to. Remember, whatever you do on the left, you also do on the right. So you're just going to multiply whatever that is on the right by the same thing. Ladies and gentlemen, this cancels, that cancels. Obviously, it's positive. Then you remain with x. Remember, whatever you do on the left, you do on the right. Ladies and gentlemen, let's apply the same approach there. So guys, obviously we're going to have x. Obviously it's a negative 3 over 2. You multiply by the same sign and you swap. Obviously it's 2 over 3. This is equals to, ladies and gentlemen, the whole of that, this is where you can put it in brackets. Okay. And remember, 1 over 8, according to that lesson that I made of the basic rules, 1 over 8 is the same as 8 to the exponent 1, which is something like that, which is the same as that. Okay, what you do on the left, you do on the right, which means you are going to also multiply by negative 2 over 3. Okay, so obviously that cancels, that cancels, that cancels, that cancels, that cancels, that cancels. You remain with x. Then you can punch the whole of this on your calculator. Let's punch. So just so that you are able to see clearly, into 1 over 8 close to the exponent negative 2 over 3. I'm getting 4, ladies and gentlemen. So that means our x value is 4. Shreyas, unmute your mic. I want us to conclude that interpretation that you initially had. Shreyas, now
Yes,
that I
sir.
got my x value as 4, remember, it means, according to that question, they simply said what number, when you say 2 minus 16 into that number to the exponent negative 3 over 2, it must be equals to what, Shreyas?
0.
It must be equals to 0. So does it mean, now that I got my x value as 4, when I substitute it there and I punch all of that calculator and I get 0, what does it mean about that x value?
It means that that according to this equation, that 2 minus 16 bracketed by 4 close brackets to the exponent of negative 3 over 2 must equal to 0.
If it's not equals to 0, what does it mean, Shreyas?
That your equation is wrong.
Shreyas, it means
Sir?
the final x value is wrong. Nay.
Yes, sir.
100%. Ladies and gentlemen, let's try to prove if our final answer is correct. So that means we're going to say 2, punch it on a calculator, guys. 2 minus 16 into 4 close to the exponent negative 3 over 2. This must be equals to, according to Shreyas, it has to be equals to 0. So guys, let's punch. Whoever gets an answer, just unmute your mic and mention the answer that you get, so that we see if we are all on the same page. So ladies and gentlemen, I'm done with my calculation. What are you guys getting as your answer when you substitute over there?
The answer is 0.
Who got a 0? You can just mention your name. You just say level 0.
So I got a
Linda
0 as well.
0.
So it seems like most of us are getting 0, which is an indication that that x value is correct. So let's see where we score some marks. I'm sure there you score a mark, ladies and gentlemen. Where else can they give you a mark? Obviously, you know, also there they can give you a mark. So I was saying, guys, obviously, you know, if you have done everything correctly, you are going to get all the marks. So they can give you a mark there or wherever. You just know that 3%, 3 marks is in the bag. Ladies and gentlemen, anyone who's got a question before we move to the next question? So guys, does it mean we are all on the same page? So to me, silence has always meant to say understood. So, ladies and gentlemen, let's prepare to move to the next question, which is question number 6. So this question is allocated 4 marks. So I'm just going to quickly write it down. Shreyas, you can unmute your mic. 3, 2 to the exponent x plus 1, the whole of that divided by 2 to the exponent x minus 2. Shreyas, what is this? Can you just explain to us what is this problem?
So this is an expression. It's an expression.
So
which we have
yeah, go for it.
Which you have to simplify in order to get your correct answer.
100%. So that means you can mute your mic. So that means when we've got an expression, we just need to simplify. That's it, ladies and gentlemen. So we've got this. We want to write it in its simplest form. So normally, when you're given an expression similar to this one where you need to simplify, firstly, check if your basis cannot be further simplified. I'm not really sure of how to explain this. For example, if that 2 over there was 4, and you've got 3, maybe there it was, let's say, 8. Then there, 2, you've got 9. You know, obviously, this, you were going to write it as 2 to the power 2. Then you work it out with whatever that was there, just like 3 minus x minus 3 over there. 8, what is it? Is it 2 to the exponent 3? I think 8 is 2 to the exponent 3. Then you're going to have that. You multiply. There, I think that is 3 squared. Then you're going to multiply. But in this case, already they've given the base in its simplest form, where you cannot say the base to the exponent something it's equals to 2. Can you see? So if you notice, you've got this simplified base, then all you need to do is to try and expand. So Shreyas, this is where you use that rule. Remember, there was a lesson that I did where I teach all the maths basic rules. So you use that rule which says a to the exponent m plus n is equals to a to the exponent m multiplied by a to the exponent n. Okay, so this is where you now use that rule. The reason why you need to expand, it's so that you can see if you've got common factors which you can take out. Obviously, you've noticed there you can come out with a common factor which is common to that term over there. So now we've got 2 to the exponent x, which is the same as 2 to the exponent negative 3. Remember, we've used that rule. Minus, to not get confused by that negative sign. When you use that rule, just separate it with its sign. If it was a positive there, I was going to have positive 3. So you've got 3 multiplied by 2 to the exponent x multiplied by 2 obviously there's 1 there, which is not necessary to write. But for argument's sake, let me just write it. There, at the bottom, we've got 2 to the exponent x multiplied by 2 to the exponent negative 2. Okay, so the reason why you had to expand is so that you can check if you've got a common factor that you can take out at the top over there. So it seems like we do have a common factor, which is 2 to the power x. Then you write everything inside the brackets. You've got negative 3 minus 3 multiplied by 2 to the exponent 1, which is not necessary. Remember, guys, a multiplication sign can be represented by a dot or that multiplication sign or just nothing. For example, a dot a, it means a multiplied by a. Guys, 2 times 4, that's equals to 2 times 4. I've used that sign. So 2 or 3, nothing, then y. You know this is 3 times y. So now I need you to notice the difference. When you multiply 2 letters, you use a dot. This is to avoid a case where you say x multiplied by x. Can you see? We are no longer sure if this is x to the exponent 3 or this is x multiplied by x. Can you see? That is why we use x dot x. Then we know this is x times x, which is x squared. Okay, so we use that multiplication sign when we multiply only the numbers. Okay, so it's 2 multiplied by 7. Guys, why are we not using a dot? It's because it might seem as if it's 2 comma 7. Can you see, ladies and gentlemen? So that is the reason why when we multiply numbers, we use that sign. Okay, massively important, ladies and gentlemen. So guys, why when we multiply a number and a letter, we just leave it as it is and not write something in between? It's because imagine writing 3 multiplied by y. 10 years down the line, you will think this is actually 3xy. Can you see? So that is why we just write 3y. With other people, they've got some funny handwritings, ladies and gentlemen. They can just write that, which seems as if this is 3 minus y. So guys, can you now see the difference in each and every equation? Please notice that you've got a multiplication and also what type of a multiplication sign you've got over there. Massively important, ladies and gentlemen, that you are aware of this type of information. Remember, at the bottom we've got that. Okay, so we had to take 2 to the exponent x as a common factor so that we subtract, we cancel those 2. Can you see? Now we remain with that which can easily be punched on a calculator and therefore get the actual value. So can you see, guys? Initially, we had a dot over there in between, a dot over there in between. Okay, so when I get to this stage, I don't need to do a dot because I know I'm multiplying a number and a number. That one, I've taken it out as a common factor. Then I use that sign just so that I don't confuse the examiner or the marker to say this is 3,2. Okay, so now on your calculator, you can punch the whole of that. So you start with a fraction button. You say 2 to the exponent negative 3 minus 3 multiplied by 2. At the bottom, you've got 2 to the exponent negative 2. It equals 2. I'm getting, guys, if you've got a calculator, what answer are you getting? Remember, when you give an answer, just say promise 13. Lerato negative 90, just so that I know who got which answer. Guys, are you still there?
Linda, it's negative 47 over 2.
Okay.
Shreya's negative 47 over 2.
Okay. Promise, Lebu, Linda, Dimpo, are you guys still there?
Yes, sir.
Negative 47 over 2. Seems like this is an answer that most of us are getting. So, ladies and gentlemen, I had a way of proving if my final answers for this type of questions where you simplify, I had a way in which I was able to prove if my final answers are correct. So it seems like they're going to give a mark, a mark, a mark, and a mark, and this is how you score yourself 4 marks. So I'm just going to remove all of this and test if that method still works. So, ladies and gentlemen, because our final answer it's negative 4, negative 47 over 2, I used to substitute that value where I see x and punch the whole of it. And when I punch is equals to, I must get that same number, which means if I got 2 as my answer, I was going to substitute it where I see x and still expect to find that same number when I punch an equal sign. So that means I'm going to have 2 to the exponent negative 47 over 2 close minus 3. Minus 3 multiplied by 2 into negative 47 over 2. You can just start punching all of these on a calculator. 2 to the exponent negative 47 over 2 close minus 2. So based on my explanation, ladies and gentlemen, I must get a negative 47 over 2. If I do not get that, then it means there's a possibility that my answer is not correct, or there's a possibility that I did not substitute it correctly, or there's a possibility that I did not punch it on a calculator correctly. Ladies and gentlemen, what answers are you getting when you punch all of that? Remember, mention your name and let me know what answer you get. Guys,
Linda,
are you still there? Or is Linda?
negative 47 over 2.
The other one, Level, what I'm getting there?
Answer, sir.
Negative 47 over
Same
2.
answer. Lerato, Shias, are you winning there?
Yes, sir.
Promise.
It's
Yes,
negative 47 over 2.
Negative
Negative
47
47
over
over 2.
2.
Dimpo, are you still there? Okay.
Yes, sir. I got the same answer.
100%. So, ladies and gentlemen, can you see with this type of equations or this type of problems, you can simply just substitute your final answer to check if you get that same final answer. In that way, you are able to then confidently say you scored all the marks. So, ladies and gentlemen, before I get to that question, is there someone who's got a question on that question number 6, or did we all understand? Silence to me has always meant to say all is in order. So, ladies and gentlemen, let's now move to question number 7, which is 3 square root of 9. It equals to 243. Ladies and gentlemen, the unknown can be placed at funny positions. So you can see now we've got a type of an equation where our unknown is there. We also have some equations where we've got a base, then maybe our exponent can be maybe somewhere there. And again, we can have x as the base, which is maybe to the power 7 over 2. So that means it's very, very much important, ladies and gentlemen, or maybe we can just have an unknown, maybe plus, let's say y is equals to whatever. Ladies and gentlemen, it's very, very much important that with all this type of with all these different positions where your unknown is positioned, you are able to approach those type of questions, and also you know your starting point. Massively important, ladies and gentlemen. So I just want you to notice something. Remember guys, I think I've explained this to say square root of x, this is the same as x to the exponent 1 over 2. Where is that 1 over 2 coming from? If you just have a square root, just know you've got 2 over there, which is not necessary to write. Just like when you have 1 over there, which is not necessary to write. Where is that 1 coming from? Ladies and gentlemen, you know there's 1 there, which is not necessary to write. So that is the reason why I'm saying this is the same as x. You start with that 1 over there, which is 1 over this, ladies and gentlemen, which is 2. So can you see, this is how you get that x to the exponent 1 over 2. Guys, it doesn't end there. If you've got y square root of x to the exponent c, let's say this is a rule, one of the basic maths rules. So this chapter falls under, I think it's a SATs, ladies and gentlemen. If you need to learn more about this, just look for that chapter called, I think it's a SATs. So this is the same as the base, which is x. Then it's c over that which is y. Okay, so let's try to say this is the rule that we are going to apply on that given problem. Shreyas, it doesn't matter whether it's given in a funny way, however it's given, just know that this is an equation, which means we need to solve, and we are solving for the unknown, which in this case is represented by letter x, which means in the end we have to say x, it's equals to whatever. As soon as we get our x value, we can then try to use that value to prove if that x value is wrong or correct. If it's wrong, it means we could have made a mistake when we were calculating for the x value, or otherwise we could have made a mistake when we substituted to prove if the answer is correct. So, ladies and gentlemen, in this case, they are saying what number, when you say that number square root of 9 will be equals to 243. Okay, based on what I've explained, ladies and gentlemen, this is the same as 9 to the exponent 1, which is that one over there, over that x. This is equals to 243. That remains as it is. So remember, guys, now that we've got our unknown, which is in that position of the exponent, we need to rewrite that 9 whereby the base cannot be further simplified. Remember, 9 is the same as what? I think is 3 squared, isn't it? That remains the same. Everything else remains as it is. So obviously, that exponent multiplies that, which means we've got 3 to the exponent 2 over x. And this is equals to, then it gives you a challenge to say, what number, when you say 3 to the power, that number gives you that. So I'd normally say 3 to the exponent 1, check what answer I get. 3 to the exponent 2, 3 to the exponent 3, 3 to the exponent 4, 3 to the exponent 5, 3 to the exponent 6, 7, and 8, whatever. I just keep on doing that until I get that. So the reason why I'm saying 3 is because on the left side I've got 3 as a base, so it serves as a guide in terms of try 3 to the exponent, let's say maybe 4, it's equals to, it's 81, edit that 4 and say 5. So it seems like with 3 to the exponent 5 you get that answer. So 3 to the exponent 5, it gives us that 243. So because the bases are the same, which is what we wanted for the bases to be the same, then they fall away. You can just equate the exponents, which means 2 over 6 can be equated to 5. Ladies and gentlemen, now we need to solve for x. I'm not really sure, ladies and gentlemen, if it makes sense. I'm just not sure if I missed something, or otherwise if I've done everything correctly. But I think so. I think I've done everything correctly. Let's continue, guys. So obviously, you know, there you've got over 1. So you just cross multiply, which means you've got a 5x when you cross multiply, then you've got that times that, which is equals to 2. Obviously, you divide by 5. Whatever you do on the left, you do on the right, just so that that can cancel, which means your final x value is 2 over 5. So quickly, ladies and gentlemen, let me just quickly try to check. So according to that rule, it's going to be 9. There's 1 over x, which is equal to that. Then 9 is 3 squared. Then it multiplies that. It becomes 2 over x, which is equals to 3 to the 5, because that is the same as that. Then, because the bases are the same, you can now equate the exponents. When you equate the exponents, you know 5 over 1 is just that. So you're doing that so that you can cross multiply. That times that, it's equals to 2, and that times that, it's 5x. Then you divide by 5 so that they cancel. You've got 2 over 5. Then this is your final answer. Which means when I say 2 divided by 5, square root of 9, this must be equals to 243. Ladies and gentlemen, can we try punch that on a calculator and check what answer are we getting? Then I've got 2 divided by 5 close. Inside I've got 9. Ladies and gentlemen, what answer are we getting when we punch on a calculator?
243. 243.
243.
So it seems like most of us are getting 243. Ladies and gentlemen, obviously, this question, it's allocated 3 marks. Okay, so where are you getting this marks? Massively important, ladies and gentlemen. Very, very much important that you are aware of exactly where you score your marks. So I think between these two steps, you might score your mark over there, and again, for that you might score a mark. And lastly, obviously, for your final answer, you will get a mark. So guys, before we move to the next question, can you just indicate, ladies and gentlemen, are we all on the same page? Did you understand that calculation over there?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
100%. 100%. So now let's move to our last question. So let's see. We've got 4 to the exponent x plus 8. It's equals to 9 times 2 to the exponent x. So this is question number 8, where we've got x, that 4 to that plus 8. This is equals to 9 dot or multiplied by that. And this question is allocated 4 marks. Ladies and gentlemen, from what I've noticed is that for problems given to 1 mark, 2 marks, 3 marks, and 4 marks, that is something that you have done before. If you do practice a lot, if you do watch more of my lessons, you will realize that questions which are allocated marks up to 4 marks, they are not that much complicated. There's nothing tricky there. There's nothing new. You just need to apply the same approach to a different type of a problem. So, ladies and gentlemen, in this case, it seems like one of those tricky questions, but I know we have done this before. Regardless of you not knowing the starting point, what matters the most is for you to be able to check if everything is written in the simplest form. Trias. It doesn't matter whether it looks complicated or not. What matters the most is that this is an equation. Why? Because there's an equal sign over there. What does it mean? It means we have to solve. What are we solving? We solve for the unknown. What is the unknown in this case? The unknown is represented by letter X. What does it mean? It means our final answer has to be X. It's equals to something. So that X, which is equals to something, when you substitute it, then punch and get a number, it must be the same as whatever that X value there. You punch 9 times 2 to the exponent, that X value, you must get the same number. So now let's check. 4, it's not in its simplest form. 8 is just a number. 9 is just a number multiplied by 2 to the power X. 2 it's in its simplest form. So what do I mean, ladies and gentlemen? I mean 4 can be written as that. Then anything else, write it as it is, ladies and gentlemen. Then this multiplies that. Then you have 2 to the exponent 2x plus 8. It's equals to 9 times 2 to the exponent x. Ladies and gentlemen, you can see when you get to this stage that it seems like you've got a quadratic because of that squared over there. And again, if you try to transpose and take out 2 to the exponent x as a common factor, inside the brackets, you will still have 2 to the exponent x. So when you notice you've got a quadratic, remember, this is where you can apply that type of a calculation where you say let whatever equals to k. So remember, this can be expanded as 2 to the exponent x times 2 to the exponent x. Anything else remains the same. So if you are not simplifying that, write it as it is. If you are not simplifying that, write it as it is and only write differently what you're simplifying. Remember, guys, this is from that rule of a to the exponent mn. You can expand it to a to the exponent m plus n. No, it's not like that. It's times a to the exponent n. So the tricky part in this case is that you've got 2x over there, but obviously you know that x plus x is equals to 2x. So that means I've just expanded like that because I know when I say 2 to the exponent x plus x is the same as 2 to the exponent 2x, which is that one over there. So ladies and gentlemen, remember, because I noticed this is a quadratic problem, a quadratic type of a problem because of that squared, then this is where you can say let. They normally use k. It's equals to 2 to the exponent x. So in short, it's more like you're saying examiner. Because now it's a little bit complicated for me to solve. Let's just simplify it a bit to say wherever I see 2 to the exponent x, I'll just temporarily write k. Okay, so you can use y, you can use d. My name is Desmond. You can use, let's check, you can use L for label, P, promise, L, Lerato. Who else is on this lesson? L for Linda, S for Shreyas. It seems like Dimpo is gone. So remember, guys, this lesson, I think it's recorded. So in case if you enjoyed this lesson and you feel like you want to or you would like to watch it in the future, just let me know in the group sometime during the week to share a link. So ladies and gentlemen, we've told examiner that wherever we see 2 to the exponent x, we will temporarily just write a k. So we see 2 to the exponent x there. It's been multiplied by itself, which means we've got k again, plus 8. This is equals to 9 multiplied by k. So you can see over there 2 to the exponent x is equals to k. So this times that, it's obviously k squared. You can just transpose, it changes a sign. So straight away we are writing it in the standard form. Then plus 8 is equals to 0. Shreyas, the standard form, we want to have it in a form of a x squared plus bx plus c, which is equals to 0. So a in this case it's 1 there. B in this case it's -9. C, that c means constant, which is 8. So we need to arrange that in that manner, whereby we start with letter squared, coefficient, letter, then we have a number. So that is what we mean when we say we rewrite it in the standard form. Why did we have to rewrite it in the standard form? It's because we want to factorize. So Shreyas, you can notice that in most of the questions, especially where you've got a squared or a quadratic equation, you need to factorize. So obviously, it's not complicated to factorize this one. So you've got 8 and 1, which gives you 8. So because in this case, you've got a positive there, so the bigger number between these two signs takes the sign of the middle term, which is negative over there. So because our constant is a positive value, we are forced to have a minus there. So obviously this equals to 0, that equals to 0, then you transpose. That means on this side k is equals to 1. Or k is equals to 8. So remember, guys, we said examiner because it is a little bit complicated. Let's just assume k to be 2 to the exponent x. Now that we've got the value of k, but remember, we said the unknown from the original equation is x, which means we are solving for x. So we cannot end it there because the examiner doesn't want us to give the value of k, but they want us to solve for x. So we say k, remember, it was represented by 2 to the exponent x. Then you can say it's equals to 1. Same here, it's equals to 8. Remember, guys, 1 is the same as anything to the exponent 0. So 1 is equals to anything to the exponent 0. It doesn't matter if that anything is a letter, which could be any letter from A all the way up to Z. Ladies and gentlemen, it doesn't matter whether that A is any number. It could be, I think, even if you say negative 4 to the exponent 0, in brackets, I think this will still be 1. Doesn't matter whether it's 0. I'm not sure if 0 to the exponent 0 is 1, but I doubt. Let me just quickly confirm what I'm saying, guys, so that negative 4 to the exponent 0 is 1. Yes. Let me test with 0. 0 to the exponent 0 is an error. So that means, ladies and gentlemen, it's not just anything, but it could be a negative number or a positive number, but not 0, because it seems 0 to exponent 0 is an error. So if we say 1 can be something to the exponent 0, in this case, we can just use 2 to say 2 to the exponent x. It's the same as 2 to the exponent 0. Why did we specifically choose 2? It's because we wanted the bases to be the same. Because we know when the bases are the same, they can fall out and we equate the exponents. That means x is equals to 0. Okay, so on this side, we also need to rewrite that 8 in its simplest or in its other form, whereby the base is 2. So what number, when you say 2 to the exponent, that number gives you 8. Already we know 2 to the exponent 3 is equals to 8. So the bases are the same, they fall away, you can equate the exponents. So that means x is equals to 3. So ladies and gentlemen, you are most likely to score your marks somewhere there. But one thing for sure, you might score your marks there. Maybe your x values are given some marks, and again for writing it in the standard form, it might also give you a mark there. Then you score yourself 4 marks. So now, guys, let's try to prove if our answer is correct. Someone substitute a 0 there wherever you see x, and check if whatever answer that you get on this side is the same as on this side when you substitute 0 there. So I'm going to choose those who can substitute using 0. Promise, Lerato, substitute with 0. And the rest of the guys substitute with 3. 3, 3. And let me know, guys, if when you substitute 0 there, you get a number which is the same as on this side. And again, substitute, the other guy substitute with 3 where you see X. Get a number, substitute again on this side, and tell me if you get the same number. Guys, are you still there?
Then 0.
Mm-hmm.
If I substitute with 3, it's 72 for both sides.
72 for both sides. Anyone else to confirm that? So now that
I
you've
also
got
Yes,
72,
sir. It's 72 on both sides as well.
okay, what about 0?
72 then.
9.
So if you substitute with 0, it also gives on both sides 9.
100%. 100%, ladies and gentlemen. So, guys, is there any of you who maybe has got a question with regards to this calculation? I know Shreyas, he's in grade 10. I wouldn't expect him to understand unless if he does understand, then it's a bonus for him. But with the other guys, do you guys understand that calculation? Does it make sense?
Yes,
Yes, sir.
So,
Yes, sir,
ladies
it
and
does
gentlemen,
it does, so I do understand it.
ladies and gentlemen, I'm very much happy that we had a very successful lesson where we were able to get to the last question without any confusion or any um, frustrations or anything similar to that. So, guys, this brings us to the end of our general lesson for today. Hopefully, tomorrow, if possible, we might look at a physical sciences related problem. I'll just check based on my schedule. So, ladies and gentlemen, it's unfortunate I don't get a chance to either record some videos where I teach these lessons, especially for physical sciences, because obviously during the week I'm at work. Only in the afternoon I'm getting a chance to do just a few lessons. So over the weekends, that's when I get a chance. That's why today we had this lengthy lesson. But otherwise, ladies and gentlemen, I hope you enjoyed this lesson as much as I did. And this is that time where I need to sign out and say, my name is Desmond, and I'm out.
Thank you, sir.